Welcome to this mini symposium on marine science and technology, legacy and challenge from Kochi. I'm the coordinator of this symposium, Professor Narufumi Suganuma. First, we are going to invite Vice President Koichi Honke for the opening remark. Please, Dr. Honke.
Good morning, everyone. My name is Koichi Honke, and I am the Vice President of Kochi University. On behalf of Kochi University, I would like to extend a warm welcome to all of you for joining us at the mini-symposium titled Marine Science and Technology, Legacy and Challenges from Kochi. Kochi University is deeply committed to marine research, and our efforts have significantly contributed to advancing our understanding of the oceans and their impact on our lives and environment. As we gather here today, we have a unique opportunity to reflect on our achievements, explore the latest innovations, and discuss the challenges that lie ahead in the field of marine science and technology. We will hear from experts from across various disciplines, from the fundamental science conducted at the Marine Core Research Institute to the social implementation of marine science and technology. Each presentation will highlight the diverse applications of marine science. I encourage all of you to engage actively in the discussions and exchange ideas. Together, we can foster collaboration and inspire new initiatives that will propel marine research forward. Thank you for being here today. Let's make this symposium a fruitful and enriching experience. Thank you.
Thank you very much. We have 4 presenters today, starting from Professor Yuji Yamamoto and guest Professor Tsuyoshi Ishikawa, who's going to talk about the Kochi Core Center project. And the second speaker is going to be guest Professor Yuki Morono and Professor Masao Iwai, who is going to join us from the vessel Chikyu. I'm not really sure whether they can successfully join us. So we have a video for Dr. Morono's presentation, but I wish we have the online presentation from Chikyu. And the third presenter is going to be Professor Masanori Hiraoka and Associate Professor Takuji Namba, who's going to talk about their project about the land-based aquaculture and its application. And the fourth presenter is going to be Mr. Hideharu Komiya, specialist at PMDA, Japan. His presentation is right now going to be presented in Japanese, but he will prepare the English version soon, and that will be uploaded later. So the first presenter, Professor Yuji Yamamoto, and guest Professor Tsuyoshi Ishikawa. The podium is for yours, and welcome.
So today, I am the guest professor Ishikawa-san will introduce Kochi Core Center and basic concept of natural science research using marine core. This is our beautiful research center building. If you can make an in-person visit, you can see this nice building. Okay, so first of all, I would like to briefly introduce the structure of Kochi Core Center, which is common name adopted in June 2006. Kochi Core Center is a research facility jointly managed by Kochi University and Jamstec. Each institution have different objective and common objective. And each institute have each function. And this slide summarizes the important function of each institute. And most important is the promotion of IODP. This is our common objective between two institutes. And today, in this talk, I would like to focus on promotion of IODP, geoscience research in Makuri, and joint usage research center activity in Makuri. And in later, guest professor Ishikawa-san will introduce Jamstec Kochi. So let's start with our faculty members in Makuri site. In Makuri and in Kochi Jamstec, we are doing a variety of geoscience research. In Makuri side, we have a very diverse research activity, and it's difficult to summarize in just in one slide. But it is probably one of the representations which our faculty staff are conducting researches. As you can see, the a variety of researches are doing here. At the moment, we have 9 faculty staff doing this research. These researches are more or less related to marine core and marine. And Kochi Core Center, in the Kochi Core Center, the most important objective is promotion of IODP. And I would like to briefly explain the current ongoing IODP scheme. IODP is the abbreviation of International Ocean Discovery Program. Actually, this is the second phase of IODP. I will slightly add explanation in later. And the program period of this second IODP is starting from 2013 and end in this year. And in this program, the most important is the international marine research collaboration in basic science. As of July 2021, 22 countries are participating. It includes Japan, United States, and European countries. And this program explores the Earth's history and dynamics, and using ocean-going research platform to recover data recorded in seafloor sediments and rocks, and monitor subsea floor environments. About the ocean-going research platforms, this is summarized in the left-hand side diagram. As you can see, the United States provides the joyous resolution platform. Japan offers the Chikyu. Chikyu is operated by Jamstec. And the European Consortium ECO offers the mission-specific platforms. This is a basic scheme of IODP. And here, what is seafloor sediments and rocks? In very short words, we can say that seafloor sediments and rocks are recovered usually as marine core. Marine core is strata recovered in columns from beneath the seafloor. And it is the result of deposition of particles of various origins. It means that it is the continuous record of past environment, including past magnetic field of Earth. This is my specialty. But marine cores, it is easy to alter in ambient conditions of normal temperature and pressure after recovery. So, in the IODP program, not only there are ocean research vessels, but also the large refrigerated storage for marine cores are important aspects. So, in other activity of Kochi Core Center, we offered a large refrigerated storage for marine cores for IODP program. Here, the typical condition is temperature is 4 degrees Celsius and humidity is about 70 to 80%. And it's difficult to define the capacity of core length, but in some definition, we say 67 kilometers for building A and 150 kilometers for building B. And actually, our Kochi Core Center, about half of the buildings are the large refrigerated storage for marine cores. In the IODP program, including previous programs, many marine cores recovered from oceans all over the world. This map shows the core recovery sites by the current IODP and previous related programs. In the current IODP, this ocean is divided in 3 regions. All regions indicated in purple, green, and dark green. And please take a look of this region highlighted in purple. This is named by KCC. It means that any cores recovered from this area in the IODP programs or previous related program. Cores are stored in Kochi Core Center. And Pacific for Texas A&M University and Atlantic Ocean for Bremen University. So Kochi Core Center is acting as a core, huge core repository for IODP programs. That's why we have so huge refrigerator here. And in the previous slide, I mentioned that not only the current IODP program, but also the previous related programs. This slide summarizes the history of IODP-related progress. The most important is the DSDP, ODP, and first IODP. In the Kochi Core Center, as a cores recovered DSDP, ODP, IODP, first phase and second phase are stored in here. And it's open for public, for open science research. This function will be introduced later by guest professor Ishikawa. And marine cores are very beautiful. So this is a very beautiful pictures. Ocean. About 70% of the globes are ocean, and oceans are have different conditions. Different conditions result in deposition of different particles reflecting the environment in each region. It results in its result in the most apparent is the color change. This color variation indicates each ocean have experienced different environment, current and first. Okay, so this is a figure showing a basic idea how Earth's environment affect to the marine sediments. So this is a very busy diagram, and it's difficult to make an easy explanation. But you can see that the atmosphere, solar activity, geomagnetic field, and ice sheet, and ocean has interacting each other by the result of the Earth environment change. And these variations are result in the deposition of particles in marine sediments. And if we do multidisciplinary analysis on sediments, we can have an idea what is the Earth's environment in past. In my specialty, I'm studying about the first variation of geomagnetic field. So my biggest interest is this remanent magnetization. But the other researchers here focus on microfossils and molecular fossils and so on. So what important is that to analyze marine sediments, multidisciplinary approach is important to have a knowledge of the Earth's environment in first. So by the multidisciplinary analysis, we can clarify the amplitude, periodicity, and timing of sudden fluctuation in various environmental factors. And this is, in short words, this is a previous history of Earth. So after we can have a knowledge of the Earth's environment in past, we can utilize it for future forecast of Earth's environment change. For the macro side, another important function is joint usage research center for drilling Earth science. In the previous slide, I explained the marine sediments. What is marine sediments and how important is the marine sediments analysis? And we offer as various equipment and facilities to use the multidisciplinary analysis for marine cores. What important is that these instruments are not restricted in the Kochi University internal use. It is open for domestic community, Japanese domestic community, and even for foreign countries. And the left-hand side diagram shows the user distribution map who used our institute via open science, open call for research proposal semi-annually. You can see that almost all institutions in Japan, it may exaggerate, but so almost all institutions in almost all prefectures in Japan researchers coming here to use instruments. And user distribution is not limited to the Japan. You can see the global map. This joint usage research centers in Japan, it is authorized by the Ministry of Minister of Education, Culture, Sports, Science, and Technology. Sorry. And about 100 such centers are authorized. But in terms of reading our science, our research institute, Makuri, is the sole institute authorized as a joint usage research center. And we are very proud of offer our instruments for open science, particularly for analysis of marine cores. So we have such a illustration to advertise our activity for community. And this activity we initiated from 2004. And from 2004 to present, you can see that the number of the approved conducted proposals are increasing. So recently, about 150 approved proposals are studied here using our open facilities. And most important is the publication of the paper as a result of joint usage research center activity. This is the figure showing the number of publications as a result of joint usage research center activity for past 7 years. About 100 papers published as a result of our center's activity. And please have a look over the bar graph highlighted in gray. Gray bar indicates the papers by researchers affiliated with institutions other than Makuri. It means that these research centers are truly utilized by the outside community users. And it is a good indication how we promote open science in Japan and in the world. And another characteristic number is that orange bar with red numbers. This is the papers that include researchers affiliated with institutions outside Japan. This is an index how we are active in international collaborative research. So we have a lot of paper outcomes. And if I heard a full half-day presentation, I can introduce all publications, but my time is very limited. So I'd like just to show the 2 examples of outcomes. first outcome, recent outcome is the basic analysis and permanent storage of the big core, which was selected as a candidate for the Anthropocene global boundary stratotype section and point. Anthropocene in Japanese is Jinshinsei. And the candidate core analyzed here is very much contributed to the application for this GPSS candidate. Unfortunately, recognition of Anthropocene was postponed or rejected, but the concept of this Anthropocene is very important. And we are very proud that the candidate for we are storing here for open science. And another topic is my publication. And using IODP core, we can investigate first variation of Earth's environment, including geomagnetic field. And utilizing IODP cores, I recovered the oldest continuous record of relative intensity of the paleomagnetic field. I skipped the detailed explanation, but Earth's magnetic field is varying very much. And this character persists at least since about 40 million years ago. So as a final slide, I'd like to slightly mention about the International Ocean Drilling Program in future. In the current IODP program, the program ends at this year. And post 2024, third phase of IODP will start. And there are very different point between third generation and second generation is participation of United States. This program, Japan and the European Consortium promote the open science research using marine cores. And this is a schematic diagram. So at the moment, this is probably the only illustration and the concept open for public, and I cannot say more in detail. But in next year, we can have more explanation. Okay, thank you so much, and please continue the presentation by Ishikawa-san.
Good morning. I'm Tsuyoshi Ishikawa, a Deputy Director of Kochi Assoc and also a guest professor of Kochi University. As Yamamoto Sensei explained, the Kochi Core Center has a unique management system, jointly managed by Kochi University and Jamstec. I talk about Jamstec science story. Our institute is Kochi Institute for Quantum Research. Jamstec was founded in October 2005 in conjunction with the commissioning of our drilling vessel Chikyu in the same year. Jamstec is a national institute making integrated research of the oceans, GS, and life. And our headquarters is located in Yokosuka in Kanagawa Prefecture. You may know about our facility or project like Chikyu, Shinkai, Earth Simulator, or DoNet. This is the organization of called Jamstec. We have one research group that is geomaterials science research group, including the specialists of rock mechanics, geomicrobiology, and geochemistry. And also, we have another group, technical support group, including the members for working for core curation and technical assistance. currently 8 staff members of Kochi Jamsec is joining Makuri Kochi University as guest professors or guest associate professors like this. And the unique thing is they include the staff for working for curation. Actually, they are IODP curators. In addition to the specialists of rock mechanics, geomicrobiology, and isotope geochemistry. As Yamamoto Sensei explained, IODP is very important for the Kochi Core Center. And it is important for Jamsec also, because the Jamsec is implementing organization of IODP in Japan. And Kochi Jamsec is in charge of curations of cores from the this powerful region from West Pacific to the Indian Ocean, taken by DSDP, ODP, IODP projects in the past 50 years. And what is important is these IODP samples are supplied to the researchers in the world. On the request from the researchers. Our IODP curators are handling typically 200 sample requests from the world, like this. And one sample request includes several tens to hundreds of sampling. So they are handling first number of core samples per year. And some researchers are visiting KCC for sampling by themselves, both from Japan and international. And since 2007, over 1,500 papers have been published on studies using these IODP and legacy cores created at the KCC. And they include the ones, these top 1% and top 10% papers like this. So clearly, this curation contributes to the global geoscience greatly. And let me introduce some recent topics of our institute. The first one is on rock mechanics, on IODP expedition 370, carried out Nankai draft of Morono Peninsula. Hirose is our director. Hirose-san et al. Found during this drilling a transient upwelling flow of raining mud, like this, or from the borehole, and it provides the first direct evidence of an overpressured aquifer around the plate boundary fault. And such a high pressure patches around the deep region is maybe related to the occurrence of strong earthquakes along the Nankai Trough. The next one is on the geomicrobiology. I here show the two topics. Importantly, both of them are the result of collaboration with Kochi University. And first one is the discovery of dormant microbes in 100 million year old deep sea sediments from the South Pacific Gyre by Morono et al. And they found such microbes in very old sediments are still alive and can revive and multiply still. And second one is research on microbial diversity below seafloor by Hoshian et al. They made a comprehensive DNA analysis of many marine cores taken from IODP and others. And they found the marine segments have different microbial communities like this than seawater and topsoil, but similar overall diversity despite the dark, limited environment. And the final topic is on geochemistry, and they showed that asteroid Ulva is a drifter from the outer solar system. They made high resolution and precise analysis on the samples from the Hypsa 2 project and showed the Ulva particles were formed in the outer solar system. After the present position. This is not the result of marine geoscience, but this provides an important clue for understanding the origin of water and organic materials in the earth. Finally, this is a group photo of the KCC in April. This student performing KCC. And Sano sensei is here, and our director Hiroshi is here, and Yamamoto sensei is here, and another vice director Iwai sensei is here. I am here. So I no doubt the joint management of KCC is fruitful in community and also in science. Thank you for your attention.
So next presenter is guest Professor Yuji Morono on his the work on the microbiological study.
Hello, my name is Yuki Morono, a researcher at Jamstech Kochi and also a guest professor at Kochi University. I'm now at the offshore Tohoku, 200 kilometers away from the coastline, to join the research expedition happening right now. I will be on board until the end of the October. I'm sorry, I plan to attend online from the ship, but because the operation will happen sometime soon, so then I decided to switch to the recorded presentation. I hope you can understand the situation and enjoy my recorded presentation from now. So my field of research is the subsea floor biosphere. As you can see in this cartoon, we are going to the ocean by using a ship like we are doing right now and lowering the pipe down to the seafloor, where is the starting point of our research field. And it is well known that enormous amount or number of the microbes are living in the subsea floor environment. And our research target is the why they are there and how they are living and what extent the living environment continues in the subsea floor environment. And looking back in the literature, the paper can be found published in the 1955, so almost 70 years ago. At the time, the subsea floor biosphere was only 7 meters below the seafloor. So the researchers found colony from the subseafloor sediment, but nothing more than 7 meters below the seafloor. They could not find anything, any colony formed. So the conclusion of that research was the extent of the biosphere below the seafloor was only 7 meters. But after years or decades, we have found many of the microorganisms living in the subseafloor environment, even at the very oligotrophic, energy-poor environment, at the very center of the Pacific Ocean, and also very deep, down to roughly 2 kilometers below the seafloor of the subseafloor environment, and also up to a very high temperature zone, roughly up to 120 degrees C of the subseafloor environment, we still find the life. So it says that microbes are everywhere almost, and we haven't found any limit of the biosphere yet. What makes difficult in the subseafloor biosphere research is that this point, microbes are minor components in the geological matrix of the subseafloor sediment. So this is my understanding before getting into joining JAMSTEC. So in the subseafloor sediment, microbes are living something like this, and somehow easy to find them, but it was completely wrong. Actual thing is that in volumetrically, microbes are minor constituents, even at the very high concentration of the microbes, which is 10 to the 9th microbes per cubic centimeter. Even with that, it only corresponds to less than 0.01% of the volume of the entire matrix. So we are having the much higher number or volume of the grains or non-biological matrix in the subseafloor sediment. So then we must have a way to access that kind of minor component of the microbes. So like this picture. So we can only find the microbial cells at the very center, but anything else is the non-biological grains. And my experience of the subseafloor research is that it had been very difficult, and it was almost no chance to apply existing technology as is. But we could have found many new things, and it was very interesting that majority of the deep biosphere research is the unexplored stuff, and although it is very challenging, but pretty much rewarding field, I think. So to tackle the very challenging subseafloor samples, we have accumulated the appropriate technology to look for the life in subseafloor samples. One of that is the selective detection of the microbial cells in the subseafloor samples, namely cyber discriminative cell enumeration, we call cyber DICE method. In here, we apply DNA dye, such as cybergreen one, we are using this one. That dye is adsorbed to the sediment particles as well. So if you apply that in the low concentration, all of the grains are making fluorescence, and it is very difficult or almost impossible to discriminate or define which one is microbial cells or which one is non-biological material. But what we found is that if we apply that in a very high concentration, 250 times higher than the company recommendation, then DNA cybergreen 1 complex stays green, whereas the non-biological particles turn into yellowish color, which we confirmed by the taking fluorescence spectrum like this. And if we get that in the microscopic image like this, so by the optical microscopy image, we cannot say which one is microbes, but by the color of the fluorescence, we can say this one and that guy was microbial cells, whereas the other particles stays yellowish color. So pretty much discriminative detection was possible. And also we extended that to the some kind of the automated manner by taking the greenish color fluorescence image and also the orange color of the fluorescence image and made image calculation. And the resulting image is like this. So we almost eliminated the non-biological material signal and only could detect the biological signal from the subsea floor sediment, and resulted in the very clear microbial abundance profile, whereas the before that we had a problem in the selective detection of the microbial cells. So that is why we got very wrong data set from the subsea floor sediment. And the other aspect is the how to make our technology to be very sensitive. So for that, it was necessary to separate or extract microbial cells from the sediment matrix. And the clean working environment was another important factor to enhance detection sensitivity of us. So the separation was done by creating the layers of the density gradient solution, which make the very high efficiency of the cell recovery or separation, regardless of the type of the sediment. So like before, like this, and after separation or concentration of the microbial cells, we can get this kind of the samples after separation process. But microbes are everywhere, including the surface of our skin and also in our mouth or gut or everywhere. So the contamination from the surface environment is also very critical. So that is why we created the horizontal laminar clean flow room, which now we call as a super clean room. And also on board, we have the portable type of the clean working system. Then we can have the very clean environment to handle the subsea floor samples without having the surface contamination. And also, it was very difficult to say the living status of the microbes. Are they alive? So then we introduced the tracing microbial activity by feeding with stable isotope level substrates. So this technique was introduced. So what we did previously is that having the mini core samples. So this is the subsea core sediment samples, and place the drop of the substrate solution. So like the bicarbonate, glucose, pyruvate, acetate, or amino acids, and also the nitrogen source, and applied a little bit oxygen because this is from the center of the Pacific Ocean, and the oxygen penetrates deeper in the sediment. So that is why we incubated that oxygen environment. And then after that, we separated microbial cells, as I explained earlier, and we further purified microbial cells by using the PAX technique, fluorescence activated cell sorting technique, and obtain this type of the samples. So starting from this like of the sample, we could purify microbial cells in the high density, and did the nanoscale secondary ion mass spectrometry analysis to do a single cell level of the substrate incorporation of the stable isotope. And this is an example of the results. So by using these nanosims, we can obtain the ion map showing the abundance of the 12C and 13C, for example. Then we can get this kind of the graph showing how much of the substrate added is incorporated into a microbial cell body. And found that the microbes living in the 100 million years old sediment were actually alive and able to eat the added stable isotope level substrate. So the top part says the bicarbonate added incubation, and the lower part says the amino acids added incubation. And the left-hand side shows the DNA staining results. So that is showing microbial cells stained, DNA stained microbes. And the this one shows carbon stable isotope labeled substrate incorporation and then nitrogen substrate incorporation. And blue said that almost no incorporation occurred. So in the case of bicarbonate arid condition, the little purple says that a little bit of the incorporation occurred, but not much of the carbon is incorporated in here. But in the case of the nitrogen added condition, some of the microbial cells incorporated added nitrogen source, which was ammonia in this case. So showing the activity of the nitrogen substrate incorporation in the microbial cells. And also in a case of the amino acids amended condition, it shows clearly that they love amino acids, but there were still several of the microbes didn't like the added substrate, so didn't incorporate any of the added substrate. In total, we found more than 70% of the subsequent microbes were readily metabolized added substrate, so it means they remain alive. Even after 100 million years after burial in the subsequent sediment. So actually, for publishing this paper, it took 1.5 years. And one of the critical points that the reviewer raised as a concern was this: have they been there since burial? And we looked at carefully the environment they are buried. So the sample are from here, so 100 million years age of the sediment. And above that, we had thick porcelainite layer. Porcelainite is kind of the rock, very tight as a structure, and the microbes cannot penetrate, and water is even the water is very difficult to penetrate. And so that is we're acting as a blocker to block the penetration or intrusion of the new microbes layering upper of the layer. And also we looked at the pore size from the permeability and the empirical equation to derive the pore size. And the size was found to be way smaller than the size of the cells. So the microbial cells were estimated to be very like this. So they are buried and they cannot move, and they just are going to the very starved condition throughout the years of the burial. So then the question raised: so how old are they? And how did they survive? Is the question came to next. And by looking at the literature, how low the microbial cells could survive or maintain its abundance in the cultured condition. And in the literature, we found that this is the lowest possible energy for microbes to survive. So this says the 19 atmol at watt. So it is the at is a minus 10 to the minus 18. So very small energy they can survive. But in the case of the South Pacific Gyre, so the oceanic region, we obtained a 100 million years old sediment core. The energy available at that region is merely or the just very small, so zeftowatt. So they are living in very small amount of energy, way smaller than the known low energy microbes. But recent paper could tell something about the survivability or the way to survive for the subsequent microbes. It's the supply of the hydrogen. So this is something like a cryptic process. So something like an unhidden, unseen process because of the creation and consumption going simultaneously. So the observation cannot be done, but theoretically, the hydrogen can be produced in somehow high concentration. So that could supply energy for the subsequent biosphere, I mean the subsequent microbes. So then this tell something like the subsequent biosphere could be resort or something like acting as a prison as well, and or it could be something like the case of the extreme case of the sustainable society, because no supply of the energy compound, but they could survive by themselves. So recycling the stuff and the creation of the energy compound is the pretty much of the background for them to survive. And things we have learned from the scientific ocean drilling and what is the remaining challenges is here. So microbes could persist at the very deep and very scarce nutrient at the the very ultra oligotrophic environment, like I just explained, and very old sediment microbes survive in the very hot in the subsequent environment. And it is also known that the microbes are as diverse as the oceanic and the soil microbes. But the problem is that we haven't identified the end of the biosphere. We haven't reached that yet. And also, although we have accumulated the compositional information of the microbes, still the global significance of the subsequent communities is largely unknown. And also the sensitivity of ecosystems to environmental change is also not known. To understand the last question, microbial response to the sudden environmental change, I'm on board on Chikyu, the J-track, the name of the project. So this is not the first time to go to the this side of the Japan Trench, but 12 years ago, there was 343 Japan Trench fast drilling project. Right after, I mean, the 1 year later of the big earthquake happened in the offshore Tohoku, the researchers or scientists went there to observe what happened to the site just slipped during the earthquake, and they found temperature anomalies still existed even after 1 year of the earthquake. So here is the temperature anomaly region. So roughly around 800 to 20 meters below the seafloor, where the mega slip occurred. So because of the frictional heat, the temperature anomaly created, and the even after 1 year period, by applying the sensor array, entered into the borehole opened by the scientific research drilling ship of Chikyu, opened in the subsea floor, and they could measure the anomalous temperature. And after 12 years of the expedition, and it is actually 13 years later of the earthquake, we are back to the same location of the earthquake, and the mega slip occurred with an objective of the characterizing the stress state within geological formation, and what is a component of the geological materials, and what is the hydrogeology, meaning that the water flow are happening in the subsequent environment, which is one of the key things for the microbial life also as an objective of this entire expedition. So far, we have drilled into the formation without taking any of the geologic material. So it is called as an observation or logging operation. So with great success. And we have actually achieved the one of the deepest hole ever scientific ocean drilling open into the geological, the subsequent environment. So reached to the this 6,897.5 meters from the sea surface, which is the longest record. And this is a warned bit, so which is already used in our expedition. And one of the media newspaper website broadcasted our achievement in the project. And this is my summary of deep biosphere research and the upcoming interesting things to be learned from the deep biosphere. And I hope in this symposium you will have a fruitful discussion and enjoy rest of the presentation. And thank you for your attention.
Thank you very much. Very interesting report. Actually, the recording was done on Chikyu. So at least it was presentation from Chikyu. And the third presenter is going to be Professor Hiraoka.
Hi everyone. I'm Masanori Hiraoka from Marine Station of Kochi University. I'll introduce our seaweed culture technologies. Our presentation title is Progress and Prospects of Land-Based Aquaculture of Ulva, SeaWheat, developed in Kochi, Japan. Seaweed biomass is an important biological resource to realize a sustainable resource recycling society. In particular, green seaweed ulva is called siletus or seaweed. This seaweed is recently called by the European countries, EU, and some international Ulva research projects are undergoing. Ulva is characterized by its fast growing and doing photosynthesis and absorbing CO2, nitrogen, and phosphorus. Under optimal conditions, Ulva doubles in mass every day. It's relatively easy to cultivate, and Ulva is rich in nutrients and can be used as a resource for food and other industries such as animal feed or biomaterials. In Japan, one species of Ulva prolifera, has been used for food for a long time. This species grows abundantly in the brackish waters of river estuaries. So people have been harvesting ulva naturally growing. And in addition, marine culture technology using net has been developed to produce ulva prolifera. The total annual production of Ulva prolifera at its peak is 100 to 200 dry tons. However, Ulva production has declined dramatically due to environmental changes in recent years. Kochi used to be a place with the most natural harvest of Ulva prolifera. However, the harvest abundance had been ever 10 to 20 tons, but gradually decreased and finally reached zero in 2020. Since then, no ulva has been harvested at all. Along Kochi's coastal line, sea surface temperature are rising twice as fast as the global average. So seaweed distribution and abundance are rapidly changing. This shows the change in the types of sargassum species along the coast of Kochi over the years. In 1970s, temperate species, sargassum has temperate species and tropical species. And in 70s, temperate sargassum species grow abundantly. But in the 80s, tropical species appeared here, and after that, 90s, tropical species gradually increased, and now the most common seen in species are tropical. It's dramatical change happened in Kochi. So I explain why does ocean warming cause a decline in Ulva. And this is Ulva plant. Ulva cells, this is Ulva cells, transform directly into spores and are released. This photo shows the vegetative cells. These cells divide and multiply. The plant body grows larger. When temperature rises, the vegetative cells change into spores. This is spore. They are spores. These cells have a lot of spores in cells. The spores are released from the cells quickly, and original cells become empty. After almost all spores has been released, the empty cell leave plant body. This slide explains that again. When the temperature is high, the cell turn into spores and are released, causing the plant to become smaller. When the temperature is low, vegetative cells continue to grow, causing the plant to become larger. So it's difficult to grow seaweed in the warming oceans. So we tried and developed the land-based aquaculture. Land-based tank seaweed culture has some advantages, which are stable algal production all year round, and avoiding contamination, water pollution, and hard working. But it also have some disadvantages, which are much construction costs and running costs. So effective productivity is required for the achievement. Our land-based seaweed culture system has three characteristics for effective production. There are ground seawater supply, germinating cluster method for floating culture, and multi-step tank system. I'll explain about these. The first is ground seawater. We can pump up the ground seawater by setting a pump near ocean. The pumped ground seawater is naturally filtrated. It has stable temperature all year round and no contamination of other algae. Using ground seawater can cost cut cost of temperature control and remove contamination risk. The next characteristic is jamming cluster method for floating culture. Conventional method for seaweed cultivation is attached culture, like this. General seaweed release spores. They attach to something like ropes or nets and grow up. So attached culture is good for seaweed growth, but density control of seaweed in tank is difficult. This means it's not good efficiency for industry. On the other hand, unattached culture or free-floating culture make density control easier. New technique for attached culture was invented. Seaweed attached substratum normally grow, but without attaching substratum, many seaweeds abnormally grow or withered. We made seaweeds attached each other by themselves for free-floating culture. This is the original idea for free-floating culture. This shows how to make free-floating seaweed seedlings germinating cluster. We called that those seedlings germinating clusters. Some spore formation is induced by cutting mother plant into small pieces. The fragmented plant pieces are cultured in a glass dish. A few days after, a huge number of spores are released from the plant pieces. This is the gathered spores. Spore can swim in the water. Gathered spores put in glass dishes densely, and the spores germinate attached to each other, make aggregation. And the germinating aggregation are torn into many small clusters for germinings. And the germinating clusters are cultured in laboratory and transferred to outdoor tank. We published this way named germinating cluster method in 2008. Germinating clusters produced in laboratory were transferred and cultured in outdoor tank. We can easily control the seaweed density much high. The last characteristic for effective production is multi-step tank system. This data shows Ulva growth in 1-ton tanks and 7-ton tanks. The vertical axis is fresh mass, and it's expressed as a log scale. In 1-ton tank, Ulva seaweed mass goes up along the time course. The growth speed gradually declines when the mass density is getting higher. So to avoid this speed reduction, we transferred the seaweed to the larger 7-ton tank. Then growth speed regains and gradually reduce again. As a result, we found transferring from small tank to larger tank is important for efficient mass production. So, we also found Ulva increase by more than 10 times after 1 week culture. This is important indicated here. Based on the growth data, we designed multi-tank culture system. And this system has sequenced four steps of out of the tanks with 10 times larger volume. This can produce 100 kilograms fresh mass every week. So if we had 7 units of this system for actual commercial production, we could harvest 100 kilograms of seaweed every day, all year round. This slide shows the growth of Ulva. Small germlings increased by 10 times after 1 week, and they are sequentially transferred to larger tank. And finally, they grow up to more than 20 centimeters long. They are harvested in total 4 weeks. And this is the commercial scale facility built in Kochi in 2004. This has small tanks and larger tanks. This facility is annually producing 3-ton Ulva materials. In 2017, our student established a venture company producing seaweed using Kochi University's method. They are producing more than 9-ton Ulva materials. This shows Ulva production in Kochi. I've already told you the natural harvest in Kochi has dropped to 0 in 2020. However, land-based aquaculture is fully replacing the reduced natural production. And moreover, as new companies continue to enter Kochi, the production from land-based aquaculture is still increasing. Kochi's land-based aquaculture is spreading nationwide now. Land-based aquaculture of Ulva is being carried out about total 20 facilities in Japan. These 2 facilities each produce 5 tons of Ulva per year. This is the latest facility opened in 2024 on Iejima Island, Okinawa. Okinawa has high temperatures, so we have been able to culture Ulva by finding and using the high temperature resist strain from Okinawa. So we use that strain. The Ulva production has been successfully commercialized for food. However, for non-food uses, more efficient production is required. Recently, we have discovered Ulva species with an extremely fast growth rate. It's called Ulva meridionalis. This species has fourfold daily growth rate at a high optimum temperature of 30 degrees. It grows 10 times in 2 days. Make it highly efficient to produce and usable for purpose other than food and feed, fiber fertilizer, and fuels. This is the last slide. This is the goal of our research, seaweed or SeaWheat-based resource recovery and recycling. Producing 1 ton seaweed fixes 1 ton CO2. The seaweed biomass is used in various industries and converted back to CO2. We circulate carbon by having seaweed absorb CO2 released from the various industries. We also purify the aquatic environment by absorbing nitrogen, phosphorus, and trace metals dissolved in seawater. We also purify the aquatic environment by having seaweed absorbing nitrogen and phosphorus discharged from fishing industry, agriculture, and sewage treatment water. So now we have some research project about this. Continue to research to goal the bioeconomy. Thank you for listening. That's all my presentation.
Thank you very much for your presentation. Very, very, very interesting. And the last presenter is Mr. Hideharu Komiya from PMDA. He's going to talk about the regulation, for this time in Japanese, and he will post an English presentation later. So, どうぞ。
PMDA の小宮と申します。このような伝えていただいて、菅沼先生にご名簿してあります。また先生方のすごく貴重な、また興味深い可能性を感じる講義を拝見させていただいて、PMDA としても開発の可能性であったりとか、そういうのをすごく感じられる、そういった講演で本当にありがとうございました。大変勉強になりました。 で、私の方からは、皆様に共有できる情報としては、海洋については、あまり私の方も知識が深くないので、このようなその海洋から、開発された、または探索された、そういった技術を、最終的に製品化するときに、どういったことが必要になるのか、そういったところを少しお話しさせていただければなというふうに思っています。で、一応まず簡単に私が所属する組織のことを紹介させていただいて、で規制に絡む機関ですので、少し、私の機関の方を説明させていただければと思います。で、一応SeaWheatありません。で、先ほど申し上げました通り、本日は、私の機関の説明を少しさせていただいて、その後、私の方で少し調べた、その海洋科学の現状、開発の現状であったりとか、また今日先生のお話をお聞きして、いろいろとそんなに私の海洋科学の知識の受け売りですけども、そこまで大きく間違った情報はなかったかなと思って、少し安堵しているところもあるんですけれども、この開発の現状について少しだけご説明させていただいて、であと、2つは、最終的に、この海洋の技術というのが、医薬品とか、さまざまな、技術に応用されていくんですけれども、私どもの機関は、医薬品等を審査している、そういった機関ですので、そういったその承認審査の基本的な考え方であるというところを少しお話しできればと考えています。で、また、高知大学様におかれましても、こういったその海洋技術の応用について、研究されている、もしくは、製品化に向けて、開発を進めている、そういった事例があると思いますので、そういった事例に関して、どういうことが審査の中で見られるか、そういったところを少しお話しできればなというふうに考えています。でまずPMDA についてなんですけれども、私どもの機関はですね、もともと厚生労働省の方で医薬品等の審査を行っていたんですけれども、その審査の業務というのを一部一貫して PMDA で行うというようなところで歴史的に設立された、そういった機関でして、で私どもの機関はより有効で、より安全な製品をより早く患者さんの皆様に届けるために、日々仕事をしているというような機関となっています。で、そういった歴史的経緯もあるので、PMDA とその厚生労働省では、業務分担というのが、ある程度明確に決まっていまして、厚生労働省の方では、行政措置等の実施というものを行うんですけれども、PMDA はどちらかというとその科学的な判断ですね。患者さんにどういうふうに有効なのか、またはもしくはどういうところが危険なのか、そういったところを判断して、これは世の中に出していい製品なんだ、そういったところを審査している、そういった機関になります。で、あと PMDA の役割として、今説明したのは審査関連業務の2番目の業務になるんですけれども、それ以外に健康被害救済業務と安全対策業務というものを行っていまして、この一つは健康被害救済業務というものは医薬品の副作用があったりとか、そういった時が患者さんにあったときに、そういったその医療費の負担であったり、障害年金との給付を行う、こういった業務も行っています。また、安全対策業務、これは医薬品とか医療機器が世に出たときに、その後から問題が見つかってくる、そういったことがあるんですけれども、それに対する情報の収集であったりとか、それをまた患者さん、もしくは医療従事者、もしくは国民の方々に、その情報をフィードバックする、そういったことを行っています。で、海洋技術を応用した医療関連製品の開発というところで、ちょっと私が調べた情報ですけれども、ちょっとご提供させていただければと思います。で、私が調べた中で、内閣官房総合海洋政策本部事務局の調査ということで、これが出ていまして、で、これがすごく私としては分かりやすかった情報になるので、ここにちょっと提示させていただいているんですけれども、今日本日の発表にもあった通り、海洋でさまざまなものが 探索であったり観測、または採取されて、でそれがどんどん知の創出につながって、そこが最後、製品化に結びつくところで、私のやっているところは、この医療のところで、この医療の製品化に最後結びついたときに、どういったところが必要になるのか、そういったところを、仕事として担っている、そういったところになります。で、これが、ちょっと古い情報で、論文が取ってきたんですけれども、2016年の論文になりまして、で、これが医薬品の開発状況で、海洋由来生物に関する医薬品っていうのが、どういう状況で、承認、どういう状況かというものを、まとめた、そういった論文になっていまして、で、2016年の情報でもさらにアップデートされているとは思うんですけれども、世界では、承認された品目というのは、この2016年ですと7品目ありまして、またフェーズ3、この一番初めにあるクリニカルステータスの中で、これは臨床試験で、フェーズ3というのがほぼ結構製品化に近いような製品になるんですけれども、そういったものが3品目ぐらいあるということで、またそれ以外にも、フェーズ2、1、それ以外の探索的なものをやっている、そういったものに関しても、これだけの製品があるということで、かなりその海洋に関しても、これからのそういった技術の創出であったりとか、そういうことが期待できる、そういった技術の分野ではないかなというふうに考えています。で、ここで、最後、製品化の部分に関して、少し、プレゼンで講演したいと思うんですけれども、まず私たちは、医薬品医療機器等法という法律がありまして、その第1条の法目的に従って、仕事をしています。で、それが品質とか有効性、製品の品質とか有効性、および安全性の確保並びに、これらの使用による保健衛生上の危害発生、および拡大の防止のために必要な規制を行うということで、この規制を一つになっている組織になります。で、また研究開発の促進のために必要な措置も講じるということで、これは様々なその相談業務であったりとか、そういった技術を製品にするための相談業務というものを行っていて、それがそういうことを行っています。で、これによって、国民の方々の保健衛生上の向上というところをやっているというところになります。で、この審査の一つの考え方になるんですけれども、医療上のそのリスクとベネフィットバランスというものを科学的に考えるということを我々の機関ではやっています。で、まず、例えば医療上のベネフィットっていうのは何かというと、例えば病気が治る。これは当然だと思うんですけれども、それ以外に病気の予防であったりとか、あとは治療の時間が短くする。そういったところが一つの医療上のメリット。で、また、医療上のリスクというのは、例えば抗がん剤をはじめとして、副作用であったりとか、そういったところが、より重篤に出てしまう。そういうことが、主に医療上のリスクなんですけれども、それのバランスを見て、医療上のベネフィットが、高いもの、そういったものに関して、承認をしていく。それを科学的に、定量的に考えていくというところを、やっています。で、主に、この、製造販売承認審査、私は医療機器の方の審査を担当しておりますので、これは医療機器の方の条文になりますけど、基本的には医薬品と同じような考え方でやっていまして、主に先ほどリスクベネフィットバランスを考えたときに、例えば効能効果、いわゆる例えばがんが治りますといったときに、そのがんが、治らなかったら、それは、承認できないということになりますので、この条文の意味に書いてあるのは、そういう効能効果または性能を有すると認められないというところで、条文に、これに該当するかどうかというのを審査している、そんな形になります。で、このロの部分、これは効能または性能に比して著しく有害な作用を有することによって、医療機器として使用価値がないと認められる。これは先ほどの、リスクの方が多いとき。例えば、抗がん剤の副作用が強すぎて、これは使えない。あまりにもその毒性が強すぎて使えないように。そういったものは承認しないという ところで、それを科学的にそういうところになります。で、次のスライドが、もうそこを同じように説明しているスライドなので、これは少し飛ばして説明をしたいと思います。で、高知大学様においては、その、開発されている製品が、このような形で、海洋医学の力でアルツハイマー病の早期診断治療を目指すということで、今、開発されているところかなと思います。で、私の方が、体外診断用医薬品という審査チームにいたこともありまして、少し、この開発事例に対して、規制の中で、どういったところが、求められるのか、そういったところを少し現段階で考察してみましたので、ご紹介させていただければと思います。で、まず、この開発事例に関しては、バイセクトトーサーというものを、検出して、アルツハイマーの診断に使えるかどうかというところを、そういう製品だというふうに理解しています。で、そういったまずものっていうのは、法律の中でどういうカテゴリーに入るかというところなんですけれども、法律上は体外に何かその体の中の組織であったり血液だったりそういったものを出して測定する、そういったものを体外診断用医薬品というふうに法上はなるんですけれども、そういったところにまず該当するかどうかというところが、一つ法律的には、規制的には論点になります。ですので、まずはそういったところ、この製品はどのカテゴリーに入るのか、そういったところをまず記述する必要があるというところになります。で、次にまたその製品が、体外診断用医薬品ですと、陰性、陽性とかっていうことを判定するような検出用試薬というものと、何か値を分析するその測定用試薬という、例えば値として何かの物質がどれくらい出ますよというようなこの値に出るもの、それを測定試薬というふうに言います。また、反定量試薬というものもありまして、値は出るんですけれども、これ以上のものを陽性とする、これ以上のものを陰性とする、そういったものを反定量試薬というふうに言ってカテゴライズしています。で、またそういったその値というのが、どういうふうに医療上使われるのかというところが一つ論点になりまして、これを臨床的な位置づけというんですけれども、今回の例ですと、例えばアルツハイマー病を診断する、そういった検査には、アミロイド β であったりとか、タウタンパク、こういったものが、他の診断指標としてはあるんですけれども、それとの検査の位置づけというのをどういうふうにするのか。最終的にそのお医者さんが判断するときに、タウタンパクとか、もしくはアミロイド β を優先して、その検査結果を優先するのか。そういったところを議論している、そういったところになります。で、そういったところというのは、関連する、その医療上関連する学会があったりするので、そういった関連学会と、臨床的位置づけとか、そういったところを議論している、そういったところが重要になるところになります。で、また、こういった製品を開発するときに、先ほど血液であったり、それ以外の細胞であったり、そういった何を検査するのかというところも重要になりまして、でそこがその、使用検体の検体では最終的に何を使うか、そういったところもすごく気にする。で、またそれがその使用方法にも話としては及んでくるところなので、そういったところを関連学会ともどんどん詰めていく。そういったところが必要になってきたりします。また、バイセクト搭載に関しては、他の疾患とかで、数値が上がるとか、そういったところがちょっとあるのかないのかというところはあるんですけれども、そういったもし状況がある場合には、その疾患とのしっかりとした鑑別ができるのか、そういったところも審査の中ではポイントになってくるというところになるかなと思います。でまた、こういったその海洋由来成分、もしくはその天然由来の成分に関しては、例えば製品を大量に生産した場合に、品質というのがその均一に保てるのか、そういったところも一つのポイントになってくると思ってまして、例えば、その品質がやはり一定化しない場合に、その製品として最後バリデーションするときに、どれくらいのその、値に収まれば OK とするのかって、そのレンジが、すごく大きくなってしまうパターンであったりとかっていうのを、 が可能性としてあるので、そういったところをどこまで製品としてバリデーションできるのかっていうところも製造上のところでは問題になってくるのかなというふうに思います。でまた、こういった場合、また次です早期検出できるっていうところで、そこを目標に開発してされていると思うんですけれども、それで、正確な診断っていうのは本当にできるのかどうか、それを本当に証明できるのかどうかっていうところが、一つの課題になるかなというふうに思います。で、また、試験結果等が出てきたときに、性能であまり試験成績が良くなかったという場合でも、例えば規制のカテゴリーではないですけれども、規制のカテゴリーの中には入らないですけれども、例えば研究を主役っていう形で製品化することだったりこともできるので、そういったところも最後の出口として、可能性として考えていると、開発自体が全部なくなってしまうということはないのかなと思いますので、そういったところも最終的な性能等が明らかになったときには、検討していく、そういったところになるのかなと思います。また最後、これはもう完全に規制の話ですけれども、協力してくれる企業様とか製造する会社様あると思いますので、そういった協力企業様は製造の許可とかを有しているので、そういったところは最後、製品化する上では、重要なところになっているかなというふうに思っています。一応高知大学様のこのバイスクト搭載に関しても、とてもアルツハイマー病の、の治療の、治療薬っていうのが、最近新しく承認されたということで、とても注目度は、世間的には高いものになりますので、ぜひ、製品化に向けて、頑張っていただければと思っていますので、ぜひ、また、こういった開発が進んできて、いろいろ製品が困らないときには、我々の機関なども活用いただいて、開発を進めていただけるといいのかなというふうに思いますので、ぜひよろしくお願いできればと思います。最後、まとめになるんですけれども、私の方で伝えたかった、今回伝えたかったポイントは3つありまして、まず開発した製品にどのような規制がかかるのかっていうところを理解すること。あと、その規制の考え方を知るというところは、開発の出口戦略を考える上では重要だというふうに考えます。で、先ほど薬機法による規制のかかる製品では、製品の有効性、安全性の担保が必要というところで説明させていただきましたけれども、製品の利点とか限界というのを十分に開発者の方も、以下でも進めていただいて、で、先ほど学会の話も少し出させていただきましたけれども、その製品の潜在的な有効性とか安全性とかっていうところを、その医学の領域の学会等と連携していただいて、よりその製品を魅力的なものに、していっていただきたいなというふうに思っていますので、そういったことをすることによって、開発の出口を見据えた、堅実な開発になっていくというところがありますので、もしぜひ、こういった製品開発しようとされている、そういったことがあったときには、こういうところも少しちょっと端に置いていただいて、開発いただけるといいのかなというふうに思います。すみません、ご清聴ありがとうございました。
ありがとうございました。We have 10 minutes to go, and there's one question from the audience. Actually, Professor Honke asked Dr. Yamamoto about how you can detect the border for the new order. Actually, and I agree with you. But can I answer that question?
So I'm not sharing the PDF page of the virtual people and online, I'm showing the one page of Iwai et al.'s paper, and here you can see that there is a lot of analysis parameters, which is indicative of occurrence of Anthropocene era, radionuclides, novel materials, organic geochemistry, and so on. So after basic analysis of the big core here and sample preparation for further analysis of these aspects, this is the these are the various aspects indicative of starting of Anthropocene. And in this paper, conclude that this red horizon is all equivalent to about 1953 or something is the starting of Anthropocene, and which is subjected to the committee to decide the Anthropocene GPSS. I'm not a researcher directly participating in this project, but important part of this research was conducted in Macquarie, and Macquarie contributed to this proposal. Thank you very much. Question, Honke sensei.
So that was an explanation for the Anthropocene in whole.
Yes.
Right. Thank you very much.
先ほどの最後のご講演で、
はい、山本先生、どうぞ。はい。
正確性とか、なんかおっしゃってましたけど、
はい
なんかどれ具体的に求められる数値の基準っていうのはどういうふうに定義されるんですかね。
ご質問ありがとうございます。ご興味持っていただいてとてもありがたいです。まず具体的な値というのは実は決まってないくて、例えば学会の先生であったりとか、その臨床上求められるその精度っていうのは、例えばがんでがんを見つけたいといったときに、今までがんを見つける製品がなかったっていうような場合に、がんであれば、それを、見つけられさえすればいい。要は、見落としてもいいから、少しでもがんの人を見つけられればいいっていうようなケースの場合には、感度というか、感度という値があるんですけども、その感度自体はそんなになんていうか、良くなくてもいいから、少しでも見つけられるっていうことに利点を置いて、例えば、40%と 50% でもいいと。そういったところになりますし、逆にどんどん拾い上げたい、がんっぽい人を全部拾い上げたいっていうような検査の場合には、感度少し例えば測定試薬とかだと値をすごく下げることによっていろんな人を拾い上げてくるので、拾ってきた人はがんかどうかは分からないんだけども、怪しい人を拾い上げるっていうところで、そういった観点から臨床上のことを考えて値っていうのが最終的にお医者さんとかにお聞きして、これぐらい大丈夫ですかねっていうところで決まるっていうところです。ただ既存のものがある場合は、体外信頼用医薬品の場合だと基準が一応 90% 決まっているのがあって、その既存のものを開発する場合には、その基準に基づいて 90% 決まっています。新しいものは決まっている。
そうすると、新しいものを開発するには、どういう要件を設定するかっていうところから、いろいろ相談とか、コミュニティとか相談しながら決定していく。そうですね。なかなか難しそうな。
そうですね。高知大学様の場合には、医学部もありますし、そこで協力して、もともとの例えば、どれくらいあればいいんだというのは、結構お医者さんが分かってたりとか、あとはお医者さんも分からないような場合には、 学会のコミュニティとかある場合には、そこでこう決めていったりしていただけたりしたりするので、PMDA も実はそういった学会様とかの力も借りながら、そういったところを判断しているのがあるので、ぜひそういったところも大学様の方でも最初に検討しておいていただけると、とても出口に向かって一直線に効率よい開発にどんどん結びついていくような、そういうふうになるのではないかというふうに思います。
診断の方はそうですけど、治療の方は。
治療です。そうですね。そしたら、薬とかもそうだと思うんですけど、薬はどちらかというと、臨床試験というのがあるんですけども、人に投与して、本当にその効果があったかどうかっていうところを、基本的にはもう見るものになりまして、で、例えば、がんであれば、がんが治るというふうにした場合に、例えば300人とか500人の人に投与して、でそれが最初に生存率であったりとか、もしくはがん種によっては、がんの縮小率とか、そういうもので有効性を見たりするんですけれども、それががんが少し小さくなった、もしくは生存率が伸びたという形で、最後の評価を行います。で、その中で、有害事象とか、そういったものが、例えば、死亡であったりとか、もしくは、私たちがよく言うのは、不可逆的な、そういう有害事象、例えば、どうしても治らないような痛みが起こっちゃったりとか、そういうようなことがないかどうか、そういったところを中心に審査をしていて、で、そういったところを加味して、最終的にベネフィットの方が勝つよねっていうところを、定量的に計画している、そういったところになります。
ありがとうございます。Thank you. Thank you very much. And actually, the time is already noon right now, so this is going to be the end of this session, and we will welcome in Professor Yuji Sano for the final remark.
Thank you very much for taking time to participate in this symposium today. On behalf of the Marine Core Research Institute, as abbreviated MACRI, I would like to appreciate. As discussed in this symposium, Kochi University has applied to the JPICS under the subject name of Knowing the Ocean and Living with the Ocean. In this symposium, the role of the MACRI is to study climate change, life science, and cluster deformation from millions of years ago to the present day, using mud and rock samples on the ocean floor. Specifically, we not only store a large number of cylinder-shaped core, but also measure them using a variety of physical, chemical, biological, and geological methods, and use the data obtained to study how and why sea floors were formed. As such, it is the only laboratory in Japan that performs the entire process from storage to analysis of seafloor samples. Collection and storage of samples is conducted as International Joint Research Program called IODP, and Kochi University is one of the 3 research centers in the world, along with the University of Texas in the United States and University of Bremen in Germany. Next year, IODP will be developed into IODP 3, but our role will remain the same. Anyway, we will continue to respect our subject, knowing the earth, knowing the ocean and living with the ocean, and MACRI will work together to make JPICS a success. Thank you very much for your cooperation.
Thank you very much.